Hi everyone, I'm Chen Tong from the Information Services Group in HDB, and I used to lead the team who's in charge of designing and developing geospatial information systems, as well as exploring the use cases for 3D and immersive technologies. So today I'll be sharing a bit more about my favorite pet project, the participatory design of HDB community spaces using virtual reality. And without further ado, let me start by sharing my slides. Okay, I'll start the sharing session using a video that basically covers the participatory design workflow and how the VR application actually helps in this process.
Workshop here at Woodlands allows residents to pick the facilities they want along the social corridor, which is an existing park connector that stretches across the east to west of Woodlands. Some of the suggestions include water features, sports facilities, and even barbecue pits.
Residents first made their initial designs on boards, which then sprung to life with virtual reality.
In the past, I always believed that these workshops were very, old style, old school, but now that we have things like VR and three-dimensional renderings, that the residents can actually see what's going on as they're planning it themselves.
So essentially, the participatory design workflow in HDB follows 4 key stages, starting from sensing, which is the stage in which we try to get the most divergent views from residents regarding which places to co-develop, and also what are some of their ideas in terms of redeveloping some of these areas. So all these information we collect through post-it notes at common corridors or marketplaces, playgrounds, etc. And we take about 1 month to actually consolidate them and prepare for the ideation workshops, which are essentially focus group discussions involving volunteer residents who come in and talk to us about their proposed idea of how to redesign some of these areas. So to facilitate these discussions, we often make use of things such as the site plans, which you see in the current picture, as well as things like cardboard cutouts, as well as reference pictures to convey some of the design concepts. Now, the outcome from these focus group discussions are then consolidated and passed on to a design consultant who will take about 3 months' time to focus and converge all these different focus group ideas into a few proposed designs, which is being used at the validation stage. So the validation stage, basically, the residents will reconvene and then vote for their favorite design. And then the favorite design will then be implemented. So this process actually has its own set of challenges. Challenges in terms of experience includes the residents themselves not being able to read plans or being able to visualize outcomes that's being discussed at the focus group discussions. This can create a problem when the residents expect one thing, but then at the proposed design, they see another, so they get disappointed. And if, let's say, that few residents can actually read plans, even fewer residents can actually draw on plans to convey their ideas. So this just exacerbates the problem. And this means that plans sometimes fail to convey accurately a sense of scale, space, or constraints to the residents. And in terms of the operations, our operations, There are also some challenges in that consultants need to actually interpret this feedback from a divergent range of participants and need to craft proposed design taking into account of everybody. That takes time. That takes about 2 to 3 months typically between the ideation and validation stage. So what this means is that we need to hold 2 separate events with 2 separate logistical arrangements. So what we've done to ease the situation is to come up with a virtual reality application at the ideation stage. So how we make use of this is that we first replicate the actual sites to be redeveloped in 3D, and we do this to scale, that means 1-to-1. Then we create a library of reusable furniture that the suppliers can actually provide for those sites. And what the facilitator would do is that in discussion with its focus group, the facilitator would then drag and drop furniture from the library into the site. And because the furnitures themselves are designed to scale, and the site itself is also drawn to scale, then the proposed design is as accurate as it can be. And at the end of the discussion, residents have a clear idea of what to expect from their proposed design. And also, this means that site constraints such as the space constraint and stuff can be much better illustrated to residents, hence they have a bit more understanding in this regard. So in terms of our operation, this is also very helpful because we can now do immediate consensus building or validation at the ideation stage. So ideation and validation stage can be combined into one. This is helpful because we no longer need to host 2 separate events, no longer need to handle the logistical arrangement, invitations, and so on. But more importantly, the direct translation of residents' intent into plan means that there's much less chance for them to be disappointed. They won't forget the things that they've talked about 2 months ago, for instance. So this is what is the most crucial benefit from this arrangement. So we have tried out this solution and now use it for a number of different programs that HDB organizes, such as the Remaking of Our Heartlands initiative, which re-livens and rejuvenates selected towns. And we do so using these two and co-design the existing spaces with the residents to give them a new sense, a new lease of life, and also give the residents a better sense of belonging to those places. So sites like Toa Payoh and Woodlands, as shown in the video, are some of the sites under the Remaking of Our Heartlands program. And other tools that make use of co-design includes our HDB Buildathon, where we basically empowers ground-up groups to actually propose designs for their community spaces, and we provide these residents the VR tool as a means of rapid prototyping their designs. And these designs can then be pitched to funding panels, and the best idea will actually get implemented. Aside from co-design use cases, we also use it for visualization purpose, such as in my Nice Home roadshows that we typically organize for new residents of a particular project. We help residents visualize their new flats by using the VR to recreate the entire living space. So this helps them to actually do their interior design planning. Further, we've also used it for SIRS engagement. So in SIRS, or Selective En Bloc Redevelopment Scheme, we have to rehouse some of the residents that were displaced. So these residents have been staying in their old places for a long period of time. And so the replacement blocks have to give them a good sense of belonging as well. In order to do this, we get design consultants propose different designs and help the residents immerse themselves into this environment to see which one of them do they actually prefer. This is done using the VR tool as well. So some of the key outcomes from this initiative is that we get about 2 to 3 months of shorter engagement process, which is about half the typical time it takes for engagement. And more importantly, the residents seem to think that this tool has helped them to understand the design concepts much better and to meet their expectations much better. And overall, it's much more enjoyable process for them as well. So this is really a win-win situation for both HDB as well as the residents. Now, the next segment of my sharing involves the learning points from this journey that we have building this app. So I would like to split it into 3 distinct concepts, right? Application, which are things to consider when you design the VR app. People, which is basically ways that you can handle first-time VR users much better. And that's the majority of them, to be honest. And thirdly, it's about the operations, which is just logistical considerations for you to have a smooth VR engagement. So starting with application. I'll just go a bit high level, but most importantly, we need to have the VR application needs to maintain a healthy frame rate. So what this means is that every single second, the VR application needs to refresh its frames by 60 times or up to 90 times per second. So failure to actually meet these frame rates would mean that the brain gets into a state of confusion where the effect that is achieved is sort of similar to motion sickness. And this can generate a nauseating feeling that can mar the experience for first-time VR users. So we want to avoid that at all costs, particularly for VR applications. Now, these are just some of the little tips and tricks that we have found out along the way that has helped us in our application to achieve the desired frame rates. We make use of the Unity game engine to design our VR application. And some of the features that we built into the application include level of detail modeling, where we have different models, the same models of varying levels of details. And we will show the more sophisticated model when the user is closer to the object, and then we'll show the higher performance but less refined models when the users are further away from it. When done right, this can actually not matter much in terms of user experience. So in terms of things like shaders, which are just instructions to your graphic processing unit or GPU in terms of how to render 3D objects, you want to use those that are more optimized for mobile application development as well. This will increase the performance. And in terms of lighting, now lighting can make or break the application, right? Good lighting is required to provide a sense of realism, which is also important to VR, but it is computationally expensive. So what we'll typically do is to make use of pre-computed lighting information, which means big lighting. And so all these information will be pre-computed and stored in what is known as light maps. And so the system can easily just paint the models accordingly. Now, in terms of textures, which are the skins that you will use to wrap around your 3D model to create that effect of realism, you want to make use of texture atlases, which means you pack all the different textures used by the same model into a single file, so that the GPU does not have to make unnecessary trips to load different files, thereby decreasing the overheads and hence creating a better frame rates. So in terms of culling, which is basically a feature that hides all the information that is not seen by the camera. This is a useful tool to help you avoid unnecessary rendering, which can save on rendering costs and increase the frame rate as well. So these are just some of the general tools that we use. Now, aside from maintaining a healthy frame rate, what is important is also to have smoothing for the cameras that are used to project what the user is actually seeing in their VR experience. And most common mistakes is that when doing this sort of projection, the application does not do any camera smoothing. And when the VR user is actually donning the headset, they can get quite excited. They just look up, down, left, right. It can result in very jerky movement for the external viewers. So we want to avoid that by smoothing the camera. And we also want to have really simplified controls and design the app for as much self-help avenues as possible, such as integrating tooltips within your application itself so that the user can just see what button to press for which purpose. And we also need to ensure that the VR experience can be both handled by the users themselves as well as by their guide or their handler externally. So this means that when users don't actually get a hang of the VR application, the guide is able to help them navigate by using some backend controls. Now, in terms of people, as someone who has been working on the project for a long period of time, working with VR for a long period of time, we can easily forget that most people haven't used VR before, and it's not intuitive to most people. So it's important not to overwhelm them. So we always walk them through the controls, teach them which buttons to press and so on to get what effects going before we actually put on the headset for them. Next, we need to make sure that the guide can actually see what the user is also seeing in the experience, because the users have weird ways of getting into unexpected situations that if you are not able to see what they're seeing, it's very hard to guide them. Thirdly, we want to broadcast the experience of the user to a wider audience as much as possible, because VR is usually an experience that's consumed by one person, the individual. So it's important that people who are in the queue waiting for their turn also gets to enjoy this experience, and hence we'll be able to extend the reach in this engagement. Now, in terms of operation considerations, I think the most important thing is to choose well-shielded locations, which are locations that can be easily cordoned off, or maybe choose a corner in an indoor space. This is important because open spaces is actually quite dangerous, where people walk past the play space, and then users who are actually donning a headset cannot see where they're going and then bump into them. And secondly, it also affects the performance of the sensors of the VR and confuses them a bit. This is the same reason why you want to avoid spots with sunlight penetration or the possibility of rain. And that's because technology used is infrared, and sunlight actually interferes with infrared as well. Similarly, we want to avoid spots with heavy audio-video equipment. Somehow seems to interfere with this as well. Next, you want to be choosing the right VR delivery platform. There are basically two types of VR solutions out there. One is the tablet VR solutions, which are basically the heavyweights like Oculus or HTC Vive. And these are really good for interactions because they are these well-developed controllers and it's sort of intuitive for the users in terms of interaction. But if your solution does not require interaction or it's mostly focused on viewing consumption, then perhaps you want to increase the reach by using mobile VR solutions instead, which can be actually deployed on smartphones and have a wider reach. Thirdly, is about decreasing the turnaround time. Because as mentioned earlier, VR is actually consumed by a single person at any one time. So it's really important that we decrease the turnaround time to increase throughput. And we have found that what is particularly helpful is to have at least two guides stationed at each station. One to explain to the current user of the VR equipment, and the other to explain what to expect to the person next in line. Lastly, the handler should be prepared to actually navigate the users who navigate for the users who are preferring to have a lower interaction mode, or basically people who just cannot get the VR UI no matter how hard you try to communicate with them. So for these users, we want to make sure the app actually has controls for the handler to teleport them to the desired location so they could enjoy the process by just turning their head around and consuming it. This basically sums up all my sharing for today. I'd like to make a special shout out to Nanyang Polytechnic, School of Interactive and Digital Media. It's basically their students who have helped us build up this VR capability along the way through the internships they had with HTB, and also the ones who helped us develop the application and refine it across different batches of interns. With that, I've come to the end of my sharing. If you have any questions, I'll be happy to take them. Thank you.